Hello, my name is Avantika Vyas, and I'm going to explain you what Mac access control is and the reason for specialized Mac. Why do we require a specialized Mac? So here I will explain you its two basic and major problems. Those are as hidden and exposed terminals and near and far terminals. So before diving into this, let me first introduce you with what Mac is. Medium access control or MAC is a sublayer of the data link layer in the 7-layer OSI network reference model. MAC is responsible for the transmission of data packets to and from the network interference card and to and from another remotely shared channel. So, the basic function of MAC is to provide an addressing mechanism and channel access so that each node available on a network can communicate with each other node available on the same or other networks. Sometimes people refer to this as the MAC layer. Here in the diagram also we can see that the second layer, data link layer, is comprised of LLC and MAC. So, motivation for a specialized Mac. Since Mac schemes from wire networks, for example, CSMA CD, as used in the original specification of IEEE 802.3 networks, also known as Ethernet. So, Ethernet is defined by data link layers and physical layer protocols. They both comprise the Ethernet. So, how the CSMA CD of Ethernet works? Carrier sends multiple access with collision detection, which works as following. A sender sends the medium wire or coaxial cable to see if it's free. If the medium is busy, the sender waits until it's free. If the medium is free, the sender starts transmitting data and continues to listen into the medium. If the sender detects a collision while sending, it stops at once and sends a jamming signal. So this is how it works in the wired connections. So what makes it impractical for wireless? Since CSMA-CD is capable of detecting the collisions at sender's end only. Well, it does not cause any problem while communication is through a wired connection because if a collision occurs anywhere in the wire, everyone will notice it. The situation is different in wireless networks. The sender detects no collision and assumes that the data has been transmitted without errors, but a collision might actually have destroyed the data at the receiver. So these are its two basic problems are hidden and exposed terminals and near and far terminals. First, I'll introduce you with hidden and exposed terminals. So, to understand this problem, let's consider three devices as A, B, and C. Um, Here, B is reachable through A, but A cannot detect or see or send anything to C. That is, C is almost like hidden to A. Similarly, C can transmit data to B, but cannot see or detect A. uh, A is hidden to C. So, but B can reach to both A and C as well. Now, when a time comes when A and C both senses B as being idle, so they both thinks that okay, B is free, our receiver is free. Let's send our data to it, and they both try to send the data to B, and it results in the collision. So here we can say that A is since A was hidden to C and C was hidden to A, they both sent data to the same terminal, and and it resulted in a collision. Exposed terminal, while hidden terminals may cause collisions, the next effect only causes unnecessary delay. Now consider the situation that A sends something to B and C wants to transmit data to some other mobile phone outside the interference range of A and B. Here, A is trying to send something to B and C is trying to send something to D. But and both C has a different interference range from A and B. But C senses the carrier and detects that the carrier is busy as A's signal is propagating in this. So C postpones its transmission until it detects the medium as being idle again. But as B is outside the interference range of C, waiting is not necessary. Causing a collision at B does not matter because the collision is too weak to propagate to A. In this situation, C is exposed to A. C is exposed to A. C is unnecessarily waiting for A to transmit its data to B, which has no any reason, which has no any valid reason. Its next problem is near and far terminals. So consider the situation as shown in figure, as the A and B are both ending with the same transmission power. As the signal strength decreases proportionally to the square of distance. That's what happens with wireless networks. B signal rounds out A's signals. As a result, C cannot receive A's transmission. Now think of C as being an arbiter for sending writes. C acts as a base station, coding media access. In this case, terminal B with already drawn out term in A on the physical layer. C in return would have no chance of applying a fair scheme as it would only hear B. See here, A is near to B and C is far away from B. So whatever A propagates, B will receive it really soon rather than C. So C will have this drawback of being away from the from the receiver. So this should not be this should not happen in wireless networks. All the all the wireless signals should arrive at the receiver with more or less the same strength. Okay, so otherwise a person standing closer to somebody could always speak louder than a man than a person farther away. So these are two basic problems because of which the wired connections, CSMA, CD, and other protocols cannot be used with the wireless networks. And for wireless, we use TDMA, FDMA, SDMA, the combination of these for the communication. Okay, thank you.